Okay, I think I'm live. Let me just share my screen with you all. Okay, my screen is visible, one of you, right? Let me read the problem statement pretty quickly. You're given zero indexed array, nums of length and consisting of non-negative integers for each I from 0 to n minus 1. We must determine the minimum sized non-empty subarray of nums starting at I that has the maximum possible bitwise or minimum sized. Okay. In the words, let's be a okay or na, because in or we all know that if it would have been asked maximum sized, then all the elements of the array would have been the answer. So no issues. Okay. In the words, let bi be the bitwise or of the subarray. You need to find the smallest subarray starting at I, such that the bitwise or of the subarray is equal to maximum bik, where I okay. Array number return an array number of size and with the answer of I is the length of the minimum size of array starting at I with the maximum bitwise or starting at I with the maximum bitwise or. Okay, great. The subarray is continuous, empty, non-empty. Okay. The maximum possible subarray at any index is 3. Starting from any index, it is 3. Because 3 is at the last, right? If 3 would have been in the first, then the story would have been different. Okay. What is the length from here? It is 3. What is the length from here? It is 3. What is the length from here? It is 2. What is the length from here? It is uh, 2. What is the length from here? It is 1. Okay. What is the length from here? 2. What is the length from here? It is 1. Great. Okay. So to find the maximum possible sum, I don't have to start from the first element. I have to start from the very last element and see what is the maximum possible sum. Okay, because starting from the first element will not give me the sum, right? Great. The main thing is how we are going to find the maximum possible sum. How we are going to keep track of that. Okay, I can do something like I'll check each and every bit. If it has been already flipped, then no issues. Yeah, I can do something like that. Let me explain you what I'm trying to tell you. Okay, what I'm going to do is I'll simply mm, okay, what I'm going to do is I have to something uh, keep like vector int to just keep track of all the arrays that has been already visited. So let's say position and it's of size 32 comma minus 1. Okay, I have visited all these all these positions one. Okay, now what? Let's keep answer vector. Now starting from the, let's initialize n. Let's say I minus 1, I is greater than equal to 0, I minus minus. Okay. Now what? This is the very last index I. mm, or we are going to go back, so it is the like the leftmost index. Okay, I, and j is going to be the rightmost index, right? So int j is nothing but I. For now, let's j is I. What now? For I'll check each and every bit. For int bit is equal to 0, bit is smaller than 32 plus plus. Now I'll just check that is the value of the current element and the bit, if that is 0 or not. If nums of I nums of I and or and and the position at which this or the value of bit is not equal to 0. If this is the case, uh, that means at that position at that position there is uh, no no index present, right? So I'm like using this position as a map. Okay, so position of bit is nothing but I. Okay, now, and if this is the case, after this, what if position of uh, the what if position of the bit is not equal to -1? What if this is the case? mm, just update it. That is, I update with the maximum one. So j is nothing but maximum of j comma position of bit. Okay, this will give me the last occurrence of that element. And now update my answer of I is nothing but j minus I plus 1. Okay, return answer. Let's see if this is working or not. Runtime error, right? For this position of this is nothing but okay. Hmm. Uh, what am I even doing? So that is giving me a runtime, right? We read the code again, analyze the whole code again. Okay. Uh, why it is giving me a runtime? Null pointer, I think, because of this. Yeah, it accepted. Let me just submit this code. Yeah, it is working completely fine. So the basic idea is to keep track of the first occurrence and the last occurrence and check for each and every bit. If it is possible, like we are using this position array as a map. Okay, so what we are doing is we are initializing each and every bit last seen position to -1 for the in the beginning as -1, and for answer element we will fill up this. Okay, now the main loop is starting from n-1 to it's going to iterate to the 0. And what we are doing is at each and every bit, each and every index, we check each and every bit. If the nums of I has a certain bit set, let's suppose if it has a certain bit set, we will just update our map to the row's most recent place we have seen this bit. Okay, Understood? After that, if this is mm, I'm starting from the last element, and if nums of I is missing a bit, if nums of I is missing a bit, we need to find it later. Okay, our map that we are using position tells us the closest place at the right where the bit exists. Okay, our sub array must extend at least to that index. That's the main idea of this approach. I think that's clear to everyone. Let me see if I'm visible or not. I'm just okay. I think my approach is pretty clear to each and every one of you. Thank you so much for watching.